So, welcome. Gonna light up the room a little bit. Okay, so today we're gonna discuss code quality and high quality code. And I don't have any definite answers for this. It's basically a lot of experiences and some science stuff and some, let's say, stories or something like that on this subject. And what one programmer considers good code might be a very bad code for another programmer. So, hi, welcome. So I'm just starting up. Welcome. Please take a seat. Sure. So let's start. And no, I'm not gonna. Too many computers. So something that when I started programming, I didn't realize was that actually code rots. Even when I'm not doing anything with it, it changes. Or actually the world around this software that I've written changes. I found one indication of such change today. I'm going to see if I can find it. So the software itself didn't change, but the world around it changed. So yeah, here it is. So, soon. So here we go. So this web page is sort of a link application that I wrote a couple of years ago. And I have changed nothing. Didn't upload any new code, but you can see that there is an error message, right? So when the web hotel upgraded their software, they upgraded the PHP version, and suddenly I'm violating some strict standard. So, so this application was working before, but and it also seems that some of the links are broken or some of the images are lost. When I test it, I can see that it's still working. So every time I have my mouse over one of these, it tries to load these web pages, but it seems that some other stuff has broken also. Perhaps in this case, it's Facebook's application that I'm talking to, that I'm collecting information from, and they have changed. I haven't changed my code, but they changed. So even if I don't change my code, the world around that code changes. So we have APIs, for instance. And before I was a game developer, and OpenGL was a big deal. Sort of when I started out as a game developer, we had OpenGL 1.x, 1.1, 1.2, 1. Whatever. And pretty much when I did my university education, we got vertex shaders, another version. So they tried to keep the old API, but they added new stuff. And for games, you want it to be like on the forefront of technology. So the customer's expectation of what the application does changes. So the old blockly graphics is no longer it's no longer valid, or it's no longer, the customer won't buy it anymore, right? It's not until we got Minecraft that people started to want or appreciate blockly graphics, right? So, and actually this OpenGL changed very fast a couple of years. We also have new platforms. So you've probably heard that the web is a platform, but we also get new ways of interacting with applications. So an application that was totally fine is suddenly outdated just because we cannot interact with it the same way as we used to, or we would like to interact with it in new ways. So suddenly we got smartphones and we got tablets and we got Google Glass, perhaps. We got intelligent wear and stuff like that. That will change how we interact or expect to interact with applications. So old application will rot. And actually, the code itself will rot, since we're probably going to like change or want to change how the code works in order to keep up with this world around it. So when we change the code, we're actually going to rewrite some stuff of it, and we probably have forgotten other stuff. So we're bound to make mistakes when we change the code. Yeah, no, wrong computer again. So when we change the code and the design erodes. So, and that is because when we read or when we write the code, we have some idea how it works. But later on, when we get back to the code, we have forgotten how that worked. We can see that when we change code, we sort of leave these bits of code that is no longer used or no longer valid, but we dare not to touch them because we've forgotten what they do. So it's sort of these islands of code that no longer anyone knows what it does, but we'll leave it in just for safety. You also have something that is called architectural drift, that we had some idea of a design. Perhaps we're using model view controller as a pattern. But when the application changes, we sort of forget how that worked. Or we're sort of introducing small mistakes that turn into bigger things. There is what is the name? Liknelse. A saying in a very popular book that I cannot come up with the name for, that says that if you break one window of a building, it's going to attract people who wants to break more windows. So we don't want to be the first one who pollutes a code. If the code is totally fine, we don't want to be the first one who does the ugly things in this code. But when someone has started to add ugly things, it's going to attract more ugly things. And if you see that this code is totally about ugly hacks, again, fulhack, it's going to attract more fulhacks. It's going to attract more ugly code. So we're going to drift and we're going to move away from the beautiful code. And sometimes, I guess you have done this, you've copied some concept of the code just to make sure that you don't break the old code. You copy it and you create a new version of it with small changes. And perhaps that is fine, right? But it's not good design. Perhaps it solves your problem at the moment. Someone asked for 2 of those and you created those. A problem that I think the big issue is really when we are coding, we are problem solving. So I wrote this piece of Java code. And I didn't see the problem because it wasn't a problem when I wrote the code. And you probably don't see the problem either because it's not your problem right now. But if I say that you're going to start up this application, and this is the main method, that is the method in Java that gets run first. Right? When you start an application, the main method gets run. So the problem here is that, okay, you can read the code, right? You can see that it has a console view, so you guess that it's a console application, right? And you see that certain arguments from the application get sent to that view, and also the stream system out it's sort of like echo, gets sent to that. So you guess that the console view has its dependencies injected, like it probably puts things out in the console by system out, and it probably gets configured some way by these arguments, but you don't know what arguments you're going to send. And that was the problem that I had when we're going to like start up this application after a year. So I've written the application myself, but I forgot what arguments I'm going to send to the application to start it up. And it was not visible here because I did this really stupid comments that just says that there are arguments, but not what they are, right? So I would probably need another type of documentation here to start up this application. Fortunately, I can read code, so I can look into the console view and check what sort of arguments are expected. But it would be a better idea if I constructed the program so that when I start up the application without arguments, it would give me a proper error message or a help output or something like that, right? So I could have designed this differently if I knew that sometime in the future I would need to start up this application and don't know the arguments anymore. Make sense? So at the moment, when you're solving a problem, you're focused on problem solving and not documenting, not communicating. And good code is actually about communicating. So it's sort of when you're in the middle of programming. You're trying to solve, trying to fit in things, trying to solve the puzzle, right? But you're not really focusing on telling someone else why this piece should be here. And probably most code looks like this puzzle without an image. And the solution for this would be to put an image on the puzzle so that people get more clues when they get a piece of the puzzle, right? Yeah. So as programmers, we need some kind of simple and accurate information from the system. So this programmer is thinking of something, and he asks the system and gets information back. Is it green or red? It's red. So it gets accurate, simple information from the system. So in the best case, information that someone during problem solving stored in the code. That information is kept and is in a simple language, so it's easy to like pick up that code again and understand what it does. The goal is that when we change this code, it is easy and without breaking things, and we can like trust that we've done a good thing. So in order to make sure of that, we need to like be able to implement this change. There's some room for this code. We should be able to know how to test this code, and we should like be able to tell if we did good or not. So if we change the code and don't know, it's probably not good, right? So we need to know the new requirements or the change requirements in order to test this thing, right? So someone needs to accept this code. And hopefully we get the time to refactor and repair what we broke when we added these new things, because probably was not prepared for this code. So like I did last lecture, right? Before I changed anything, I did a refactoring that left a space for the new code, right? It's sort of, I moved the other pieces of the puzzle around a little bit. I made sure that I could implement the new code without breaking other things. I made sure that I had testability. Before I even started, I made sure that I would be able to test this new code, right? I also had an idea what an acceptable solution would be, that I would actually see the items in the database. I would see them as output, and I would be able to add new things to the database, and they would be kept there. So I had some acceptance. I understood the requirements. I did not have time to refactor and repair the code after I introduced the database, because we didn't have time during the lecture, right? So I left the code in sort of a messy state. And I haven't changed it today because I haven't had time for that. So it's not always that we live in this perfect world. Something else that in a perfect world, if you do something, if you break something, if you do introduce an error or the wrong requirements or whatever, you would get feedback. The simple, effective, fast feedback again. Awesome. Thank you for the Doctor Who reference to my lecture. Second time this year, I can hear the exterminate cell phone signal. Awesome signal, but not on my lecture. Thank you. So in reality, information is gone or hidden. So I try to solve a problem. I don't focus on communicating. So the future programmer that I've said a couple of times needs to search, needs to deduct, needs to debug, needs to recreate this information in order to solve their problem, in order to understand this code again, right? And the code probably contains a lot of misinformation, since it's changed a lot of times. And during these times, if you don't have time to refactor, you're probably going to leave these islands of code, right, that no longer is valid. Nobody calls on this code anymore. So it contains misinformation. It contains bugs also. That is sort of a misinformation, right? Maybe you read the code that is actually a bug, and you think, okay, this is how it's supposed to work. Right. So, and the fact is that some changes are hard, and we don't get time to clean up. I did not have more than 2 hours of coding time last lecture, and I had to talk to you guys, so I couldn't focus on the code either, right? So it's your fault that we got some problematic code there, right? Or we don't take that time because I don't care, because it's the company's code or the student's code. I don't care. So I don't take the time to refactor and redesign that code. Yes. Actually, I do care, but okay. And the other thing was that in the perfect case, we would get feedback on every error. And that is, we don't live in a perfect world. In PHP, it's often the case that you get a blank screen. Oh, something is wrong. Thanks for the feedback. And I've seen that some of you turn off these error messages just to pass more tests. So I know that you're good at doing this. So basically what I've said before is that we have one programmer. He has some idea of some concept in the code, and he comes up with a solution. This first thing, to do this, sort of hard, right? This, but during test, it's sort of similar to this other thing. So I do that instead because it's faster, it's cheaper. So the actual thing that gets implemented is this. And we don't have a clear relationship anymore between. So the future programmer was looking at the code and wants to implement new stuff, new features, and have no idea that there is a relationship between these two, because that relationship is not visible, because it's not an explicit relationship. I'm going to talk a little bit more about explicit relationship. It's an implicit one. Perhaps a string dependency or a dependency through a global variable or something like So, information identifiers matter. So, gonna take a short turn here. So, I'm super nerdy, you know, the super nerdy thing. So that I mean, I like your reference to the doctor during my lecture because I'm super nerdy. So one of my super nerdy interests is role playing, and not the bed. Yeah. But the super nerdy things, you know, a couple of middle-aged guys meet up in a room and roll some dice, right? That kind of nerdy. So we're going to do a little bit of role playing. So I'm your boss right now. So the lady from Customer Relationships called, and she was not that happy because our very important customer, Blorg, complained about a script that was written a year ago. And Kalle, who wrote that script, is no longer working with us. So you need to solve his mess, right? The customer is really angry and wants this solved right now. So that was the role playing. Some applause, perhaps, since it was sort of embarrassing. Thank you very much. So you take a look at Kalle's code. And this is what you see. I hope that you can see in the back. Can you? No? Maybe taking a place a bit further front. So I'm gonna zoom in a little bit. We're actually gonna move to an editor where is this better? Yeah? Where we can see the code. Oh, this is the code. If we scroll down a little bit, we can see that something is getting something. We have some classes that gets created. An M is put into an MV, and then the method E is called. Okay, so what does this tell us? Okay, this one, since I've attended Daniel's lectures, this one is creating HTML, right? So it's probably a view. Oh, I know some stuff. So we can use information that we have within us to deduct new information. Okay, this is a view. It's supposed to, why didn't it include this get thing? A view should, right? It's probably because we don't have a controller. The other one is called an M. We cannot see that anymore. I need to scroll up, right? So the other one, and the M gets dependency injected into the MV. It's probably a model, right? So, and what the view does is, okay, it's keeping this in the member variable, and then it's creating some HTML representation of this, and it echoes it on the output buffer. Fantastic, solved. No? So probably, and this looks complicated up here on line 13. That is probably where the bug is, right? Where it's complicated. Where it's simple, it's probably not there, right? So let's check some output from this code and see if we understand it better. So I run the code, and I see that, okay, undefined index n. So I'm probably going to need to add this get thingy. So we can see that it asks for n on line 34, right? So let's add some. Oh, someone has already done that. So this is the output. So I just added 100 since it was in the buffer up here. This buffer is actually a good example of, since I'm sitting at Kalle's computer right now, I can see what he did last time. And that is sort of the ideal world, right? Where I can move to his, what he did a year ago. So I probably don't have that. So my intended thing for you to see would be me adding something like n equals Daniel is best or something like that. Something that is not valid input. But this time I add 100. And we can see some output. Awesome. This is wrong, the customer says. I don't know why. I don't know how. I need to communicate with the customer, but they are on a honeymoon vacation trip somewhere, and I cannot access that customer. And since I don't want to talk to the customer, since they always complain, and I have put myself a long distance from the customer, I cannot easily just call them up. So this is the actual case where we want the customer next to us when we're coding, right? If you're gonna implement someone's requirements, you need the customer because the customer knows the problem. So after a while, the customer who's super pissed off since we lost them a couple of millions by this bug says that, okay, there is one number that is wrong. Okay, thank you. Call you next time. Okay, which one? Not that easy to see, right? Anyone? Yeah, Matthias Wikström said 1. It's actually the correct one. So why is that the correct one? And how do you know? It's not a prime number, he says. Fantastic. I want to give him an applaud. So in order to understand this problem, we needed some math knowledge. We needed to know about prime numbers. But if we didn't, if this was a completely strange domain, perhaps to some of you you don't know what a prime number is, you wouldn't be able to solve this problem. Since the code itself did not explain what a prime number is. So it would probably be a good idea to add some information in the code. And this, perhaps the class should be named math or something like that. And this method here, it returns Boolean, so it's perhaps should be called isPrime or something like that. I'm not going to fix all this code. I'm just going to show you the actual error. Since, yeah, like that. Since 1 is not a prime number by definition, and we need to look up the math text to understand that, we need to start from 2 here. And if we start from 2, we're going to not end up with the prime numbers anymore. So we need to start from 0 here, so that every number that is divisible by 2 also gets here. So what is wrong with this code? Not only it is not functioning properly, it does not contain information enough for us to easily derive what it should do, right? Also, does not contain any tests. I didn't know how to test this. It did not contain any references to the requirements. Perhaps like a link to the Wikipedia page that describes prime number would have helped us a little bit, right? Yes. So identifiers matter. The names we give to classes, to methods, to variables, to members, they matter. So let's take a couple of minutes, like 2-3 minutes, and just discuss other ways than identifiers that we can store information in code. And when you're coding, what information is missing? When you have been coding, you've done some of my programming assignments where you get code from me. What did you miss? What was lost? What did you need to derive? What did you need to debug, to find? And the last question, is there something that cannot be stored? So I'm gonna start up breakout rooms, and I'm just gonna throw you into the breakout rooms. And if you fall out of your breakout room, I think that it's probably just a good idea to chat in the general chat. So let's see if it works. And Yeah. If you end up here, you can just discuss with the people who are here. Yeah. Okay. You might want to move to the other guys, right? Hi, I'm Daniel. Pleased to meet you. Yeah. You want to see how it looks? So there's a lot of screens. And you might want to mind this one. So this is my computer, so I have my lecture here, and I have my programming environment and stuff like that. I'm just going to shut off the noise. And this is Adobe Connect. Have you tried it? Yeah. So I have my students right now. They're divided into different groups. So I'm just going to move him into one of those groups. I have like 5 students in 5 groups, so 25 students online. Yeah. And they are able to discuss in their rooms right now. So they have a chat, and they have availability to talk to each other, almost like a Skype conversation or something like that.
But they're not together?
No, they're not together. They're online, so they're in all over the world or all over the country, right? Some of them are taking the course from Växjö. Okay. But I don't know if they sit together. So I'm just going to move him. Since he fell out, I'm going to move him into one of the other room. I also do, actually this gets recorded, so I probably should. I'm just going to move everyone back. Into the lecture room. Not sure why it was not moved automatically, but okay, so we're back. Just a couple of things from the campus group first. So let's start with you guys. So what did you come up with? How can things be stored in code except in identifiers?
The example that you, what do you do when you write code in like the script?
Yes.
You write param and what you give into the method.
So I have documentation of parameters, right? Yeah. Yes, this PHP documenter thingy that I do. We have comments. Yes. So any other ways online? Good naming. So from the online groups, what do you have? Anyone in the groups or anyone at all? Just write down. Error messages, yes. So what did you discuss? Logger class, yes. That is a good thing. A logger class, so that you can know what happened to the customer, perhaps, so that you can find out. What other ways are you able to store information in code? So when you're programming, how do you store information? Like the information, the requirements that you have. So we have comments and we have identifier names, right? Anything else? Let's let me give some clues. Yeah. Yeah, sure. Yeah.
I was going to say like the use cases.
Use cases, yes. Requirements, yeah, good. So I call all of these things that I've mentioned here implicit limitation. It should not be an A up there. It's because I've changed this, translated today from Swedish to English. Probably more errors like that. But it's always good to see that even the sun has its spots, right? I do mistakes, so that you can freely do your mistakes and not be too ashamed of them. Okay, implicit limitations, like documentation, comments, manual tests, identifier naming. There probably is something that I've forgotten. Oh, is the presentation frozen? You don't see the documentation, comments, manual tests. And pie chart. And it does not change. So it seems to change, for me at least, when I see what you are supposed to see. Okay. Okay, great. So what is unique for the implicit limitations is that this is interpretable. So when you read my manual tests, you interpret those, and perhaps they made sense to you, and perhaps they didn't. Or perhaps the information that I tried to store in those manual tests were retrieved in different ways by different students. And you can see the pie chart. Does not matter the text over there, it's Swedish, so we don't understand it. But the pie charts show that different students are actually interpreting the same requirement, the same test case with image and everything. You've seen my test cases, so you know them, but in different ways on the same code. So I gave the students a login application. You've seen it, right? And I gave them the manual tests, and I asked them, okay, test this application with this manual test, and they come up with different answers. Yes. So that I find that kind of fascinating. Yeah. That it can be so different, and perhaps some of these students were more thorough than others when testing, or more taking everything to the letter. Someone said that no test case was fulfilled since the time in the image in the test case was not the same as the time when they actually looked at the code, right? And that could sort of be an interpretation. Since I have an image and the time has changed, it's wrong, right? Or it's just a misunderstanding of the complete requirement that the time should be today's time, right? So it's interpretable, and also when we put this information, it's by choice. So you decide what you want to document. And you decide if you're going to have these really short identifier names, like P, or if you're going to have is prime, or is a prime number, or something like that. So you decide how much effort you want to spend on it, and what naming you're going to have. And you're going to do that with your cultural background and with your context that you're living in, and in the context of that company that you're working with, and with the mind, hopefully, of the future programmer. Who is he going to be? Is he going to be in India or here? Perhaps you're going to not want to use Swedish if he's in India. I don't know. Yeah. Okay. So I took a look at identifiers myself. And I looked at 800,000 variable names from 56,000 Java projects on GitHub. So I just randomly sampled a Java project on GitHub and extracted one file, and then I extracted all the variable names in that file. I'm using Java in this case and not PHP, just because in Java it's very easy to do such a thing. It's ready tools for that. So I found out that around 30% of the information that programmers, a random, let's say that since I do a random sample from GitHub, it's sort of the programmers that store their code on GitHub. A lot of my students, amateur programmers, professional programmers, open source programmers, but probably not the closed source programmers, right? Because I don't have access to those. But 30% of those programmers are just storing type information. It's like they have a view and we call it view. They have a string, they call it string. That kind of thing. In some cases, it's hard to know. In Java, we have these types. They're fantastic things. I sort of miss them in PHP. So we have an integer, and we perhaps call that I, right? Is that for integer or for iterator? So it's sort of hard to know in some cases. We can see that for the primitive data types, the integers, the strings, the floats, whatever, it's just 6.5% of those, like string. So when you have a primitive data type, like an integer, you want to give it some more information. It's not an int, it's something else. An iterator or an age or something like that. But in the cases of class instances, around 50% of those were just type information. In my code, I have a lot of class instances, and 70% of my such were just type information in PHP in this case. Because in PHP, we don't have these types, or we don't need to specify the type of a variable, right? So we just write the name of the variable and equals new something. So, and we have type hinting for arguments into a method, but it's by choice, right? And maybe this is good, maybe it's bad, but seems like, okay, other programmers and me seems to like putting type information into variables. If you have a good IDE, like in Java you have Eclipse, and you can just put your mouse over a variable name and you can see the type of it, right? And you can see where it's created, and you can get information out of it. So if you have like a powerful editor, you can get a lot of this information. So by storing this information into the variable name, we're like putting redundant information, right? And in PHP, if you want to know what a variable contains, what type it is, you var dump it, right? So there are different strategies to extract this information. So giving this type information into a variable, it's sort of a redundancy. Have you done this? A string, a view, a login view, and we call it LV or something like that. So I took a look at these identifier names, and then I grouped them, and then I take a look at what kind of information is stored in these. And we can find that we have type information. I've already said that. Relationships, roles, Swedish again, right? So like, okay, this is a child node or something like that. Multiplicity, this is an array. We have an S in this last name. These are not just one name, it's names. Scope, it's, so annoying. I don't know if you've seen that member variables by some programmers are called my or m underscore for member variables, or just underscore for member variable. Data content, origin of data. This data is command line string, so it comes from a command line, or this is post something because it comes from the student or the client. It could contain information on how data was transformed, like this string has been salted, or the units of something. So you have an a length in feet, so you say length feet or length meters, or time in seconds or time in hours. Yeah, sort of like that. So, looking back into the earliest ages of programming, I found this fantastic text where they described how a programmer, the role that we have is actually divided into two parts before now. The one who was thinking about the program in the early days of programming wrote it down on paper and like a math algorithm. And then someone else took this description and is going to write it into the computer, or I don't know, punching holes through a card. I have no idea. Or actually I do, but it's more fun this way. And the one who wrote the program did not need to put these types on things. So they didn't have like strings and floats and numbers and stuff like that. They have painted types. So it said that this is not a string, it's a file name. The file name was the painted type. It can be implemented by a string, or it can be integrated by implemented by a buffer of characters, right? Or it could be a class, and that was up to the other programmer, right? The one who's writing the actual code into the computer that is going to be right. So a painted type is like a subtype of the type that you have. So this number here is a radius. It's not a float. It's a radius. And radius perhaps cannot have negative numbers. I don't know. It's like an age. You cannot have a negative age, could you? Perhaps, before you're born, right? So sort of these painted types, a file name may not contain characters that are not supposed to be in the file system, right? It was like that unique string we had in the example last time. Yes. I think we need a break now. Let's take 10 minutes, 15 past 11, start again. The recording, yes. So painted types. I also had a master student who looked at some code for me, and he took a look at how programmers stored information in comments. And he did a limited random sample of Java files from GitHub. So random selection of these 56,000 projects. And he found out that around 40% of these Java files, the comments in those did not contain any information he could not easily find in the interface of a method. It's sort of like the one below, right? Param string file name. And that is actually just an argument for this method, right? It's string file name. It's almost like programmers write comments for show. It's not actual documentation, because this information could actually be generated from the source code. It's just for show. It's just to impress other programmers, I guess. I don't know. Seems like that, at least. And I see, when I watch my own code, I see that I do it a lot. And it looks so nice. I do a good job as a programmer. And I suddenly realized that most of my comments were crap. It's sort of valid to have these sort of comments, because when you have a powerful editor and you move your mouse over it again, you can find this information again, right? So if you hold your mouse over an identifier, you can see this information. So, but perhaps we should put something else than the type in it. I don't know about you. Have you been responsible for these kind of comments also? Maybe. Yeah. Aren't those comments supposed to be extracted with something like PHP doc? Yes. And in fact, if let's take this one down here. We can see that I just generated this code, and it understands that this is the constructor, or at least that this was the name of the method. And it also extracted the type information and wants me to add these descriptions. And I used to okay, remove the word description because that is painful to do, that documentation thing. I believe that the reason for me doing this is that I'm in problem-solving mode and not in documentation and communication mode. I'm still trying to solve the problem. I'm not trying to communicate right now. And perhaps it would be a good idea to slow down your programming speed a little bit and do a little bit more of documentation. I've tried to show you that during the lectures, but I cannot force myself to write a comment. If I write a good construct description up here, or for another method perhaps, maybe the name of the method or the class should be changed instead. But that is me. Yes, Andreas Anemir writes that reflection can read from PHP docs. That's interesting, I think. So yeah, maybe we can do stuff like magic stuff, so that we put something in the comments that is actually like code. In Java, there's something called Annotation Languages that you can do that. You can add stuff to the language. I'm not sure if that was what you meant. Amanda writes that I think it's hard to know when to add on to that comment. A lot of times the code is self-explanatory because the naming and the poor comments. Too much description in code may just be clutter. Yes, I agree. So, yes. Okay, so let's take a look at the professional programmers, let's say that, or what we're going to call the guys who wrote Linux and FreeBSD and OpenSolaris. So at least they're not probably better programmers than me, since I haven't written an operating system. This is C code, and there are a lot of integers. And they spend a lot of their time, so around 20 to 30% of the code is comments. And they spend that time explaining stuff that is, integers. There's a lot of integers. I was kind of surprised to see that 22% of those comments are explanation of integers, because you can in C and in C++ you can write typed integers, so to speak. You can give them another name. Instead of age, instead of int age, you can have an age that works like an integer. 70% is like data flow, control flow, and dependencies. And I think that is the important stuff. And 10% of these things, the scientists in this study think that that these can be expressed with annotation languages. It may sound like I was against comments. I'm not. I'm against duplication of information. So just a small difference. I don't think that it's a good idea to duplicate things, because when I change things, I must change in 2 locations, right? It's sort of dry, but for documentation also. And I like the idea that a powerful tool can extract information from the code instead of me writing it. So instead of me writing the type of a parameter, maybe the tool can extract that information. Yes. So the next thing we've talked about implicit, and this was voluntary, and it was up to the programmer to both read these and write these. It was voluntary, right? We could have short identifier names like P instead of is prime. It saves so much time for me when I'm writing the code. But yeah. So now we come to the explicit limitations. And type safety is one of those. In PHP, we have something that is voluntary called type hinting, right? We can say that an argument is of some class. There are some keywords in Java and in C++ that I miss in other languages. The const in C++ works a little bit different way. You can have like read-only parameters and stuff like that. Visibility is another way of expressing what you want to a programmer. I put a field as private. I put a method as private. That should tell the future programmer to not open this up, right? And it should tell the powerful tool that you cannot call this method from another method, right? Or unless it's in the same class. So by putting different visibility like public, protected, private, I'm communicating to a future programmer on how to use and how to extend this class and what I want to be hidden and what I want to expose. I've also shown you certs and exceptions. And I've shown you that I like to make sure that instances of classes, mainly model classes, cannot be created unless the correct data is put into it, right? So we have all these asserts on strings or exceptions that are thrown if the string is too long or too short. But it's really about communicating with the future programmer that is going to use this object. So I'm putting limitations on the usage. By introducing this asserts and exceptions and things, I'm putting rules in the code that says this is right and this is not right, right? There is also automatic tests. You just suffered a bit from my automatic testing systems, but or hopefully it helped you to implement these assignments 2 and 4 a bit faster. But since I saw when I gave you these manual tests that some students interpret these tests in different ways, I wanted it to be more transparent what I want. So I created this automated testing application to give you transparency. But the automatic tests here are not the acceptance test that I gave you. It's unit testing. You've probably heard about unit testing. It's like for each class that you write and for each function that you write or method, but in PHP it's called function, right? You also have a test for that. And you write it so that the test is run automatically, or that you can run the test automatically. It becomes a second compilation step that checks that you're doing the right thing. It's communication. I want the code to work in this way and not in the other way. The future programmer should know that you should be able to send that 2 is a prime but 1 is not. We could have easily made that test, right? So that is a way to communicate into the future programmer who's going to change this code what the requirements were when we wrote it. So explicit requirements are limiting the solution space. And in order to understand this, we must understand pink clouds. So I'm not puffing something weird. The pink cloud represents all the possible solutions that, let's say, we have this login application that you wrote, and every student does it a bit different, except those students who are copying some other student. So we have like 80 solutions for assignment 2. 80 different implementations that hopefully fulfills the same requirements. Every solution for that assignment is in the solution space, right? But only a few of those implements all requirements. Only a few of those are correct. Only a few of those fulfills the intention that I had when I wrote the requirements from the beginning. So the green cloud is not something that I puffed, it's the correct solutions. And each test is sort of a line that removes pieces of the red cloud. So if I have a test that says that if you put the correct login credentials, you get logged in. That is a test, and it removes all the solutions that does not do that. Right? So by adding more tests, I'm sort of removing faulty solutions. And the same thing applies for the other explicit things, and actually for the implicit limitations also. That if I have a type hinting, I remove all the solutions where a programmer is putting another type into that, like an invalid type. Or if I have a model class that is called username, and you send it a lot of like alphanumeric characters that are not allowed in usernames for some reason, and I have this assert that don't allow them, or I throw an exception that I don't allow them, I'm limiting the solution space for faulty solutions, right? But on the micro scale, not on all the requirements, on the code scale. So I try to like remove as much as possible of faulty solutions so that future programmers that don't have a clear image on what is green and what is pink, and might have been puffing a bit, can still extract this information, at least get a feedback back. So one example is using Php Unit. This is not really a part of the course. It's part of the software testing course. But Php Unit is a way of writing automatic unit tests. And they have a lot of advantages. You can, from a unit test, you can understand what is correct or incorrect implementation. You can localize what part of the code that contains an error. You can run just one test and test one class or one method. You can have different tests of different importance, so that you can have one testing suite that is very important, or one testing suite that is stuff that we have not done yet. Tests should be readable. Actually, we should call each test something with should throw exception when wrong characters in username. That could be a name of a unit test. Yeah. It's reproducible, so that I can, if I find a problem like the one with the primes, and I can write a unit test that shows that this is a problem, and I can give that unit test to a programmer, and that programmer can reproduce the bug and can understand from that test, okay, I need to change these things. Yes, it's traceable, we can debug it. phpunit.de, like most quality things, it comes from Germany. So, okay. So, okay, before we take a look at this one, how many of you have written unit tests ever? I know that some of the class have done so, since you've taken my software testing class. None of the campus students? Or at least 7 people in online. So, yes. Okay. So if we put information into the code, there is like a lag. Is it that an English word, or is it just Swedish? Lag. When you from you try something until you experience the problem. There is a delay, right? So the best case would be that if you do something that is wrong, in this case I send an empty string to a HTTP header, a Java file, and that is wrong. And the compiler knows that, so my IDE, in this case Eclipse, can find that problem and tell me this is a problem. This code does not even compile. So this I find during writing code, and that's much earlier. So if I make mistakes during writing, I can probably remove those directly, right? I can figure out this is a problem and I remove those. So that the earlier that I find something or get information that I'm doing something wrong, the better. And I try to write as much as of my code as possible to expose problems on writing. Unfortunately, in PHP, code is not compiled until you test it, right? There are some IDEs that sort of compiles things, and you probably noticed something in CS Quiz that did something similar. I don't know if you did, but there was a red dot, sometimes at least. It was a fool hack, but at least you got some help, hopefully. These tests that I talked about, this is from Eclipse, but I can run this test, so it's another step. In some cases, when we have continuous integration, this happens when I commit my files and push them to my server. So a couple of tests are run, but it could also happen directly on your local machine that, okay, run all the tests, and this should be very fast. For manual cases, this is the Swedish version of assignment 2, right? And this is a bug in my code that one of my students found. Fantastic, thank you. What he did was that I don't know if this bug is in your code. Perhaps you can check it out on Sunday, because this was on Sundays. The day, the string down there should say Sunday, or söndag på svenska, the 13th of October 2013. So my bug only happened one day a week on Sundays, because I misunderstood the documentation for the date function. So horrific enough. I do mistakes. Here are some other bugs. This left piece is a web shop. This is much later, right? This is during deployment, when the program is out there, the application is out there. To the left, we have a price there of 0. So I have a lot of things in my shopping baskets. It's super nerdy stuff like, I don't know, säkring. You know what that is in English? Safety something. Anyone know the English word for säkring? The thing that makes sure that you don't get fried when you put your fingers into the wall socket. What, sorry? Fuse, yes. I buy some fuse and a microprocessor and a thing that you put microprocessors in. Yeah, and I didn't get to pay for that. I actually was so kind that I didn't submit this order. This was not my code, right? And I hope they were happy. I don't think they answered my email, actually. And the second one is I'm responsible for that code. It's actually one of my games that I've written. It's called Caribbean Pirate Quest, an awesome game. You must try it someday. It's really a puzzle game. And this is the high score table showing other people. And there are 2 bugs here that I didn't realize until deployment. And the first one is clearly visible that this elevator, dragsko, what do we call those? I don't know the English word for that either. And it's over the text, right? So it hides the text. And I didn't know that because I'd never tried it 100 times. And when I tested this application, I never tried it 100 times. So this didn't appear until after like 9 items in the high score table. And unfortunately, I never did that. The other bug is that the elevator here is not all the way down. But I'm actually stopped here, so I only showed the 100 best. I don't show the 10,000. But a lot of more customers have tried my game and got a high score. So I guess it's like 600 items there. And the elevator shows that, but not the, you're not able to go all the way down. Yes. And sort of in this case, this Caribbean Pirate Quest was released in an era where you could not just patch things easily, because the customers here downloaded this installer on their Windows machines, and they had to install this. And in order to patch things, they had to go to my web page again and download this. So it's not easy. So it's much better and much less costly to fix things early, right? So we want that information, what is wrong, preferably here and not here. Okay. So I probably filled your heads with too much information right now. I know that, but we're in the last slides. So, yeah. So, and I've already said this. You can listen to the lectures again and get it out of those. But really, there are other sort of qualities that I've talked about during the other lectures. Like we have dependencies, like dependency to a database. And we want to limit that dependency so it does not infect the entire code. If I exchange that database for another type of database, I don't want that to affect the entire code. So I have a data access layer class that makes sure to encapsulate that dependency. So, but we also have these interfaces that encapsulate knowledge and complexity. So from the controller's point of view, the complex view does not look complex. It has only these simple public methods that returns booleans, right? And it's only 5 methods. But inside this view class, we have a lot of complexity, a lot of HTTP, a lot of private methods and stuff. So we hide that. We encapsulate things, provide simple interfaces. And something that I've learned also is that to avoid the extras. So if you go buy a burger, don't take the extra cheese. You don't need it. So, and what I mean with this is, if you add a lot of like libraries, if you have a lot of dependencies to funky stuff, the future programmer needs to know about those also. So if you cannot encapsulate them completely, you're forcing this future programmer to install all those dependencies of the right versions and stuff like that. So if you can avoid that just a little bit and use these extras when they're really not just extras, when they're really important instead, you're doing the future programmer a favor. At least that is my personal experience. Yes. And that is the last slides. Potato. So I like traceable dependencies. I like that we're connecting classes. We're not throwing weird strings or arrays of strings around. We're passing classes. They're dependencies that show up in a diagram. We use explicit constructions extensively, as much as possible, to limit this search space. And we use implicit storage for everything else. everything that does not show up in code. Why does this code do this thing? That is what we use implicit dependencies. Yes. So this was the last lecture in this course. I hope you enjoyed those. I really did enjoy giving them, at least. You know, I like to hålla låda in Swedish, to talk a lot. But we will have a workshop working a bit with code quality, or thinking about it and trying things and testing things. And yes, let's keep in touch on Slack, right? See you.